folks. So I noticed there are some homework problems that I assigned, but I didn't do an example like it in the video for integration of natural log, involving natural log. And this is an example, this is number 30. You are assigned number 29 and 31 that'll use this same technique. It says find the indefinite integral by making a change of variables. It actually goes on to give a hint that says let u equal the denominator. So that's what we're going to do. We're going to let u equal 1 plus the square root of 5x. And of course you know what we do. Once we select u, we take the derivative. Check it out. I'm going to rewrite it with a rational exponent instead. So that's 5x to the 1/2 power. And now let's take the derivative. So that would give me du is equal to, we know the derivative of 1, of course, is 0. And then I'm using the power rule over here and the chain rule, right? Because I don't have just an x to the 1/2, I have this entire 5x. So I'm going to move the 1/2 in front, so that gives me 1/2. Rewrite the inside, reduce that power by 1, so that's negative 1/2. But don't forget, times the derivative of the inside. And also, remember this is du over dx, and so when I multiply both sides by dx, that's the equation that I get. Now I do want to simplify this a little bit so it's a little easier to look at. So du is equal to, now notice the 5 remains in the numerator, so I have 5 over this 2 in the denominator, and the 5x to the negative 1/2. I take that 5x to the bottom and make it positive 1/2, and I could rewrite it back under a square root dx. Hopefully you followed all that, especially the last step of simplifying. Now here's the thing, y'all. When you look at what we have above, remember all of this down here, let's highlight it. This is u, all right? And you're supposed to have du, or at least some portion of du outside. But whenever they talk about this change of variables business, usually you're missing something outside. Okay, so I don't have an extra square root of 5x just sitting out here. So there's a strange trick that goes on here. All right, so the first thing I want to do, watch this, is I'm going to rewrite our original problem by pulling that 4 out. It's just a nuisance. So this is 4. And then I have the integral of now 1 over 1 plus the square root of 5x dx. Now keep in mind this is u. And all that leaves me with is a 1 dx. But what do I need? I need a 5 over 2 square root of 5x dx, not just a 1 dx. Okay, so here's a weird trick. What I can do is I can multiply. Remember, we said we can never multiply a variable out front to fix our issue. So I can't multiply by like a square root of 5x out front to solve this problem. But what I can do is put inside here what I need. Okay, so let's do this in pink. I'm going to put in what I need, 5 over 2 square root of 5x. I already have the dx, so I don't have to put the dx. It's already right here. That's what I need. Now, I'm not allowed to just multiply by that, right? So to fix it, to compensate, I'm going to also multiply by 2 square root of 5x over 5. Now, y'all know that's just a fancy way of saying 1. This entire pink and blue right here, that's equivalent to 1. Now, you might be thinking, oh my word, it looks a lot worse than it did. Let's talk about it. Okay, now, highlighted. Let's pick a nice color to highlight with. How about that aqua blue? This right here, highlighted, y'all, that's dx, right? 5 over 2 square root of 5x, that's dx. Now, the 2/5, I can just pull that out front. So this 2/5 right here, I'm going to move it out front and multiply the 4 by that. Remember that we pulled out a few minutes ago. The question is, what do I do with this extra square root of 5x that I don't need? Well, look, right back here, remember we have, change colors again, I'm going to rewrite our first line. U is equal to 1 plus the square root of 5x, right? Well, if I need to substitute for the square root of 5x, I can just subtract 1 from both sides, and I can say u minus 1 is equivalent to the square root of 5x. Again, how did I get that? I just minus 1. There I am. So here's what I'm going to do. The square root of 5x right here, I'm going to substitute u minus 1. The aqua blue highlighted, that is du. And this 2/5, I'm moving out front. So let's talk about what we have now. So I have 4 times the 2/5, we're moving out front. I have the integral. Okay, now again, the 1 dx and the aqua blue, that's du. I'm going to write it over here to the right. The square root of 5x that I've got circled in black over here, remember that's u minus 1. So I'm going to write that in the numerator. And then this denominator down here, remember that's just u. So I have transformed, using a change of variables, my integral. Now out front, I have 8/5. And I have the integral. Now watch this. U minus 1 over u, I can split up into 2 separate fractions. That's u over u minus 1 over u du. Okay? Let's keep going. That gives me 8/5. The integral, u over u, we know is 1 minus 1 over u du. Now I find the antiderivative. So the antiderivative of 1, we know is u, right? The antiderivative of 1 over u, which is what this section is all about, is minus the natural log of the absolute value of u. And don't forget the plus c on the outside. What do we do next? We found the antiderivative, right? So we substitute u back in. So this is equivalent to 8/5. Okay, now u, remember way back up here, and I rewrote it down at the bottom, is 1 plus the square root of 5x. So I have 1 plus the square root of 5x minus the natural log of the absolute value of 1 plus the square root of 5x plus c. Now, I'm going to go ahead and tell you, I am perfectly content with this answer. But, let me show you what they have in the back of the book, and let's talk about it. They have 8/5. Well, actually, this isn't in the back of the book, right? This would be what they had if they answered in the back of the book. They would have the square root of 5x minus the natural log of the absolute value of 1 plus the square root of 5x, close the absolute value, and then plus c1. What happened? Did I accidentally not write that 1 right there? No. Here's what they do. Whenever you have a constant as part of your answer, when you find the antiderivative or the indefinite integral, you can incorporate it into that c right there. So if we add 1 plus c, we still just get another c value. And so that's why they called it c1. It wouldn't matter. If you gave me the blue answer, I would be fine. But I'd probably write on your paper that, hey, we could just incorporate that one with that c right there. And the fact that it's called c1 maybe in the back of the book versus c really does not matter at all. So a good answer, a good simplified answer for this problem is 8/5 bracket square root of 5x minus the natural log of absolute value 1 plus the square root of 5x, close the absolute value, plus a c. Whatever you call that, c1, c, d, k, it really wouldn't matter, but c is what we usually use for the constant of integration. All right, what do you think? Crazy? Not something you would think to do, a little weird because we multiply by this wild unity fraction, but I do think it's worth trying. I want to see what you can do with 29 and 31. I'll probably throw a problem like this into your online homework as well. Hope you have a great day.